Hello, Year 10 Express 2025. In this video, I'm working through question 6 from your recent assessment task 1. The question reads, in triangle ABC, we have angle C being 90 degrees, side AC, which is this side here, we're told that has a length of 6 centimetres. Side BC, which is this side here, we're told has a length of 8 centimetres. And we're told there's a point P, this point here, which lies on the line segment AC. And there's a point Q, this point here, which lies on the line segment BC. We're told the point P is travelling from A towards C in this direction at a speed of 1 centimetre per second. And then point Q is travelling from C up to B, and it's doing that at a speed of 2 centimetres per second. And then we have this triangle here to reflect all of that information. We're told that points P and Q start at the same time. So P would have been at point A, and Q would have been at point C, and then they start moving at the same time. And we're told after T seconds, the area of triangle PCQ, which would be this triangle here, that I'm shading in yellow, the area of that triangle is 6.75 centimetres squared. Find the value of T. So basically we need to take the information we've been given, and ultimately to get an area of a triangle we need to know the base, so the length from P to C, and the height, the length from C to Q. And if we can get those two lengths in terms of T, the pronumeral that we're trying to find, then we could substitute those into the area of a triangle formula. Note that that area is equal to 6.75, and then hopefully solve for the value of T. So that's the approach we need to take. And to begin with trying to work out the expressions that can represent P, C, and CQ, I think we can make use of the speed at which each of the points P and Q are travelling. So if we start with the fact that speed equals distance over time, and I'll use T for time since that's commonly used, but it's also the letter we're using here for time. If I want to know the length of the side PC in the triangle, I can find the length of AP, this part here, and then PC will simply be 6 minus whatever AP is. And if I've begun my journey at point A, and I want to know how far have I travelled at a certain amount of time, I'm essentially asking what is the distance? What is the distance of point A to P after T seconds? And with the simple rearrangement of the distance formula, we know the distance is equal to the speed times the time. So for point P, we know that the speed is 1 second, and the time is what we're trying to find. So we can say that the length A to P, that distance, would be the speed of 1 centimetre per second times time. So actually that length, AP, is simply equal to T. So I'll annotate that onto the triangle. And more importantly, that means after T seconds, the length of PC will be equal to the total length AC, 6, minus T, after T seconds. So that's the first key side. We know that the base of the triangle will be 6 minus T. Now let's do a similar calculation to find the length of CQ. So for point Q, if we're moving from C to Q, the length of CQ at time t, after t seconds, would be the speed, and the speed we're told for point Q was 2 centimetres per second. So we'll say that's 2 centimetres per second times the amount of time that's passed. So CQ is equal to 2t, and that's all we need to do to have that length. So there's the height of the triangle. It's going to be 2t. And it might at first glance seem like we haven't needed to use this 8 centimetres. But actually that's going to become useful information later as we're solving the we're solving for the value of t. So we'll park that for now, but that will be useful information later. But for now, we've got the base of the triangle, we've got the height of the triangle, and we know the area of the triangle, so that's everything we need to solve for t. So what we can do is say, therefore, the area of the triangle PCQ is equal to 1/2 times the base, 6 minus t, times the height, 2t. And these 2's will cancel, and so we have 6 minus t times t, or in other words, 6t minus t squared. And since that area is equal to 6.75, I can therefore conclude that 6t minus t squared is equal to 6.75. And let's solve for t. And the highest power of t here we've got is 2, so we're going to have a quadratic. We're going to possibly get 2 solutions. So once we see what those 2 solutions are, we need to think, is there a way to pick one over the other? So let's just work through the process of solving this quadratic. I'll get everything onto one side so that the quadratic is equal to 0. So we'll add t squared to both sides and minus 6t, and we'll end up with t squared minus 6t plus 6.75 is equal to 0. Given we've got this decimal here, my instinct says let's just go straight to the quadratic formula. So we'll go t is equal to negative b, which would be negative 6, or 6, plus or minus the square root of b squared, negative 6 squared, minus 4 times a, which is 1, times c, which is 6.75. And that will all be divided by 2a, or 2 times 1. So that will leave us with 6 plus or minus the square root of 36. And 4 times 6.75, that will give us 27. All divided by 2. So 6 plus or minus 36 minus 27 is 9. The square root of 9 is 3, divided by 2. So therefore, we can say that t will be equal to 6 plus 3 is 9, divided by 2 is 4.5. Or t is equal to 6 minus 3, which is 3, divided by 2 is 1.5. Okay, so we have 2 values for the time, and at first glance both of them seem fine, like none of them are negative or anything, so it's not like we can strike one out right away. And I think the temptation may be to say, well, actually both of those times are valid, they're both okay. And I must admit, the first time I looked at this question and attempted it, that's what I did. I just accepted both of those solutions as being valid. But coming back to the length of BC, the seemingly only part of this question, the only information that hasn't really been put to use, it's at this moment that that becomes relevant. Because we can ask ourselves, will the length of BC at either of these times still be 8 or less? Because we know that Q can never get beyond 8 centimetres because the length of CB is 8. So we can ask ourselves, well, after 4.5 seconds or 1.5 seconds, are we beyond 8 centimetres? And naturally, the most likely candidate is 4.5 seconds, because the more time that passes, the more likely it is that we've gone beyond 8. But we know that the distance that we've travelled, the length of CQ after t seconds, is 2 times the number of seconds. So it's not a difficult calculation. So we can say when t is equal to 1.5, I'll start with the smaller one, the side length CQ will equal 2 times 1.5, which equals 3 centimetres, and that is less than 8 centimetres, so that's valid. When t is equal to 4.5, however, CQ would be 2 times 4.5, and that's going to be 9, and that is greater than 8 centimetres. So in other words, 4.5 seconds is too long. 4.5 seconds means the point Q has moved farther than it can, and so we need to strike it out. We need to say that this is an invalid solution for this triangle. So that gives us our final answer. So therefore we can conclude, therefore, t is equal to 1.5 seconds is our solution. And that's how we tackle that question. Panic boom! So I think it's understandable that this question is quite a difficult worded problem. We're making use of a bit of knowledge from year 8. I think it could be the last time you officially learn this, where we deal with speed, distance and time, and knowing that relationship. We're dealing with area of a triangle formula, but hopefully that's something you're very comfortable with. But we're putting all that information together with our knowledge of solving quadratics, and then we've got that final step of checking both of our solutions, which is always the final step of a worded problem, making sure your solutions make sense in the context of the question. And it just happens that in this question it's very easy to miss that nuance that there is a constraint on the length of CQ, and one of our solutions happened to breach that constraint. So again, as I already mentioned, that's something that I didn't get completely right when I first tried this question, so I wouldn't lose heart if that's something you did too. I think it's not the worst mistake in the world to make, but hopefully now that you've seen this, you can be all the more careful about checking these things whenever you're doing quadratic word problems. You always need to see, is there a way I can invalidate one of the solutions in the context that I'm given. Alright, hopefully now that you've seen all that, this is a question that you feel much more comfortable being able to tackle on an exam, should you see another question again like this. And thanks for watching, and tick boom. Tick